Let's do design tic-tac-toe. Sounds like a fun one. Assume the following rules are for the tic-tac-toe game on an end-by-end board between two players. A move is guaranteed to be valid and is placed on an empty block. Once the winning condition is reached, no more moves are allowed. Oh. Oh, okay. Oh, this is just actually build this row column and okay, so they're mapped to an actual one. Okay. Okay, this one doesn't seem bad. Actually, this looks pretty easy. Okay. The move is guaranteed to be a valid move, and the two players alternate in making moves. Return 0 if there is no winner after the move. Player 1 if after the move, or player 2 if... Okay. Who's X or O, you know? Assume that player 1 is X and player 2 is O. Okay. First thing is to construct the board. So, you know, we'll have of empty strings times n for n in range 4 in range of n, print self dot board. Shoot. Let me do this real quick. Okay, I guess I'll just do a 4. I swear I can do that, no? Oh, not this. Oh, no. How do I do this, like... I swear, like, it's like you can put, like... Right? Am I not tweaking? Is n not an integer? Okay. I forgot to do this list comprehension. Like, okay, so it's this for n in range of like n. Wait, why can't I do this again? I don't know why. Oh, it does work, but just... Okay, first off, it's getting a little hot. Oh, it does work. Okay. Oh, okay. It does work. It wasn't wrong. It was my method that didn't return anything correctly. Okay. So yeah, perfect. Okay. So now move. Okay. So they always be putting up valid moves, so I don't need to do any checks for that. Yeah, so self dot board is equal to row call x, I guess, if player equals 1, else or right, right. So after that, I guess state where zoom is as I guess winner. What do you return though? Oh, okay. Okay, so I think I should make a determine winner, right? And then I need, of course, I just need to pass the board. Well, I don't need to pass the board. I have the state to that. So I have determine winner, and then determine winner. Okay. Basically, how do I determine a winner? Basically, just if it's one of these valid I guess combos. I have like a wait. Is this gonna be n by n that is always fixed? Like it's always gonna be a 9 by 9 board, right? Wait, is n? Oh my god. Okay, actually I can't do combos. It's gonna be some random like weird configuration. Okay, I actually need to determine determining a winner is actually kind of tricky. Algorithmically, let me see. Okay, so for okay. Wait, how do you determine a winner again? Because this is a bit different. A player who succeeds in placing n of their marks in a horizontal, vertical, or diagonal wins the game. Yeah, so okay, never mind. So it's like a normal tic-tac-toe game. So, I guess for every row in self.board, for every call in row, if I guess call damn, yeah, I have to like algorithmically write this part. It's like a DFS kind of. Like I'm trying to like, okay, go check. There's only technically 2 diagonals I need to check, right? I need to think about this. Not okay, I think I should do like a counting thing. Like count okay, self the row column self the diagonal diag 1. I'm gonna call this one diag 1, diag 2, because there's always gonna be 2, right? Self dot diag 2, right? And then it's pretty okay. And then basically like okay, for that specific row, damn, actually okay. For the diagonal ones, it's pretty straightforward. Like if there is a winner in the diag, then this will equal n, or inversely. Like I'll do like a weighting thing. Like okay, so player 1 it's going to increment, and then player 2 is gonna decrement. And of course, if there's like a consecutive, then it's gonna be equal to n. Okay, I have an idea. I actually need to store this too. Self.n. Yeah. I have to take, of course, the negative, because like if we want like, yeah, I need to basically do for the same for basically do the same for row and column. The row and column is not making sense here. The diagonals make sense, but the row. Oh, I see. Never mind. Like I have. I see. So row, I can. I feel like I have to hold it or something. Like I need to store. Maybe I'll store. I guess rows, calls. And I'll have like a list here. Yeah, I got it now. So like rows is basically all of these. And basically if you have a consecutive of this, then that's a winner. Same thing with columns, but columns are gonna represent. Oh no, what I said was the columns, but the rows are these ones specifically. So the first index represents how many here, how many here, how many here. So if you basically if you get all ones here, if you get all ones here, that's a win. No, I lied. Each element is a row, so yeah, that's fine. Each element is a row. Yeah, each element is a row, and each element in the call is the here. Yeah. So basically, how do we determine like this here? Look at call first element. If there's 3 or -3, then that's a winner. Yeah, okay, I got it now. Okay. I think this is the optimal solution here. All right, so row is going to self.rows. Oh wait, hold on. One, if player 2 equals 1, else calls no, it's the same logic. Yeah. So like I want to decrement and increment. And they won't cancel each other out because I'm gonna be given valid inputs. Yeah. So basically, I'll know if all the rows are 1, like positive, or the same basically. If all the rows are same, then that means these are representing. So that means there is. Oh my god, I can't differentiate. How do I differentiate if it's like all of this? Oh no, if they have every single one in. Oh, okay. If they hit all rows, that means they hit a column winner. If they hit all columns, then that means they hit a row winner. Like there's like a 1 1 1 or -1 -1 -1, right? Diagonal. Oh shoot, how do I know if it's diagonal? That's the problem. Wait, what? How do I determine if it's in a position of a diagonal? Well, I think I can deduce it by the row and column. Okay, first I need to get rid of this. So row minus call. So for example, let's say this is 1. Okay, first 0 0. Plus 1 maybe. Let's do 1 1. 1 minus 0. Oh, okay. Another one here. This is okay, what? This is 0 1 2 2 2. Oh, okay. I guess if you sum it, Yeah, if you do row minus call. Not really. Hold on. There's another diagonal. This is 0 2. 0 minus 2. It's negative 3, I guess. Okay, I don't know how to check diagonals. 0 1 2. 0 1 2. How do you determine, like, how do you check for diagonal? Check for diagonal in a matrix. I don't know. I'm cooked here. I don't know. How do I check for diagonals? They have to be grouped somehow. Wait, hold on. I have an idea. First off, we notice that the diagonal is going diag 1. So when I do the math, it's kind of always equal to 0, right? Row minus call plus, or okay, why am I plusing 1? Let's just say row minus call is equal to 0, basically. 0 0 1 1 2. So basically, if there's 0, that's diag 1, right? And then another pattern here is this is 0 2. So 0 2 1. Still 1 1. Yeah, 1. Okay, where does this go? Both of them, actually, because it's in both diagonals. Okay. And then 2 minus what is this? 0 0 0 1 0 2. Okay, this is 2 0, right? And they equal negative 2 0 2. Hold on. If I plus 1, that equals n. Okay, so I noticed that they don't equal n. N minus 1 then? Okay, so if they're equal, then they go to both. No, not both. If they're if row minus 0 equals 0, then you're in diag 1, right? If row minus call plus 1 or equals n minus 1, then you're in diag 2. So where does the 1 1 go? Equals, so it goes to diag 1, and then this one like 2 minus 0 n minus 1, and then 1 minus 0 is 0. No, that's not gonna go. Okay, that's bad. I don't think that matters. I don't think the middle one, like the middle one can go in the first one, but I don't think it matters. Okay, instead of adding them, okay, what about, let me see something else. Let's see, because I remember doing a matrix problem where like you can group diagonals and stuff. Maybe it was adding them or something. Let me try row plus call, and then, so if they're equal, that's diag 1 for sure. If row plus call equals, let's try this one. We know that row is 0 plus this is that's 0 and 2 and minus 1. 1 plus 1 and minus 1. It's gonna be 2. Oh, it does work. 2, yeah, and then n minus 2. Yes, okay, does work. It works. So the formula is this. Basically, if row equals call, you're in diag 1. So we'll do I should probably do this. Self dot diag 1 plus equals move. If row plus column equals n minus 1, self dot diag, yeah, not diag 1, diag 2, right? Simple. Now the way we just do is just check the winners. Basically, I just need to check if okay, how do I check the winners? So each row element represents a row. So if all of them are the same, that means we want a column one. But which column though? No. Each element represents a column or row. So this is the first row, right? And if that row specifically has the same numbers, like if this singular element, right? Like let's say it's 3, it's gonna be like this, right? If this singular element has 0, like the same number, like plus 1, meaning like if it's equal to n, right? Yeah, if it's equal to n, then yeah, that's it. Okay. Basically, if self.rows equals self.rows, okay, I need to make a def determine winner, I guess. Self dot basically, okay, so if we just exhaust a bunch of options, so there's a case where if so like for every word in, for every character in or for every how do I use the all? Yes, I need this. Basically, okay, so if self.rows all, I need context of the player though. Frack. Yeah, I need the context of the player. Never mind. Wait, actually, yeah, just passing the player, I guess. If all rows, then return player. Never mind. I just write this here. There's no point. Right, then return player. If all self.calls, then return player. Okay, I'm being redundant. It's or all self.calls, return player. What else could be the case? Okay, if self.diag 1 equals n, or self.diag 2 equals n. And then lastly is the actual physical element themselves. If so, for every for every RC every value in self.rows, if v equals self.n, return player. If v equals self.n. Oh wait, hold on. I need to do an ABS. Return player. And then if nothing, then return 0. Okay, one mistake. I need to do ABS. Because I don't really care about... Oh, shoot. There's a problem here. What if it's -1? True? Yeah, okay. That's fine. All I care about... But what if they're all zeros? Oh, shit. I might fail this. Because it is going to start as 0, and that's going to might return true. Okay, thank God. So if all the numbers are the same, all the colors are the same, or all the diagonal is, I need to make this ABS. ABS. Then return player. Then check if the individuals is equal to n. And then yeah. Makes sense. Uh-oh. Ooh. Wrong answer. Okay. Do I need to do this? Maybe it's just only in one of these. Never mind. It sucks. Okay. Or is it one of this? Maybe it's not this. Maybe it's this. Maybe I don't need this. Like this checks for itself. Yeah, there you go. I think I just needed to check. Okay, each. If all the row doesn't matter. That's not really what we're looking for. It's just each row is elements themselves has to equal to n. Okay, thanks for watching.